I'm really excited about being here. I'm so excited. I just have to strum my ukulele a little bit to, because otherwise I'll just explode. So here's a little song saying, hooray, I can't wait to get started today. Hooray. I can't believe this. I'm just so happy to be here. But I think we have a lot to talk about. And if we don't, we've got a lot of questions we can answer. So one way or the other, we got a lot of stuff to do. So what I want to do is just get started. So I'm going to share my screen. Beep, boop. And there we go. Got the screen shared. So anyways, what we're going to talk about today is my quest to StatQuest. And it's going to be clearly explained. Now, first, if you don't already know, StatQuest is my YouTube channel. Bam! Currently, StatQuest has over 840,000 subscribers. Hooray! And my videos have been watched over 45 million times. Hooray! Every day, excuse me, there's a typo there. People all over the world watch StatQuest to learn statistics, beep, boop, 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 machine learning, beep, 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 boop, and other data science subjects. Beep, boop, boop, boop. Most importantly, people say StatQuest helps them win data science competitions, pass exams, graduate, get jobs and promotions. So far, no one has told me that StatQuest helped them get married, but maybe one day it will happen. People watch StatQuest because it makes complicated sounding things easy to understand. So here's some comments people say. Hooray. Anyway, believe it or not, creating a big YouTube channel was never the plan. Instead, when I was in high school, I wanted to be a classical cello player. That's me, back in high school. I also taught myself how to program, and with a friend, created a video game called Jimmy Quest. There was not a whole lot to Jimmy Quest, but we recorded a silly theme song that went like this. Jimmy, 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 Jimmy Quest. Now, don't get me wrong, I had a lot of fun writing code, but I was passionate about playing the cello. I used to dream about playing the Elgar cello concerto like Jacqueline Dupre. Anyways, I ended up going to Oberlin, which is a school, and I got a music degree from the music conservatory. But just to be safe, and because it was fun, I got a degree in computer science from the college. So I ended up with two possible career paths. On the one hand, I could potentially become a professional orchestral musician. Or I could become a professional coder. On the surface, being a musician seemed glamorous, at least superficially. One, you get to wear fancy clothes. And two, you get to spend time with fancy people. But the problem is that it seemed like it could potentially be fundamentally boring, at least to me. There's lots of other people that think otherwise, but to me, I was a little nervous that becoming a professional musician might be a little boring. That's because Beethoven wrote his Fifth Symphony in 1808, over 200 years ago, and it hasn't changed much since. Don't get me wrong, Beethoven's Fifth Symphony is awesome, but playing it every year for the rest of my life, that might get tedious. In contrast, being a coder seemed like the exact opposite of glamorous. Superficially, or at least superficially, right? You wear jeans and t-shirts often, maybe not always in the office, but at least where the places I was working as a coder was pretty relaxed. And to be honest, the fancy people tended to avoid coders. We were sort of our own group of people. However, it seemed fundamentally exciting, at least to me. I mean, some people may not think coding is exciting, but to me, it seemed really exciting because languages, frameworks, problems, everything in computing is always changing. The problems I'm going to solve today are very different from the problems I'm going to solve 5, 10, 20 years from now. Now, despite the fact that I actually like to dress up from time to time, and I think it's cool that I once talked with Yo-Yo Ma, a super famous cello player, in person, and thus the superficial things of it about being an orchestral musician had some appeal. I ended up focusing more on the fundamental differences between being an orchestral musician and a coder. Now, I had had a few opportunities to talk with professional orchestral musicians, and they were a pretty sad group. They were all burned out, and they had lost their passion for the music. Just as I had expected, playing Beethoven's Fifth Symphony every year for your whole life gets boring. So the thing about music being fundamentally boring was actually something that I'd seen in real life. People had verified that my suspicion was true. So ultimately, I picked coding over being a musician because I wanted a job that would always be exciting, at least for me. Bam? No, not yet. Although I came to the conclusion that being a coder was fundamentally exciting, it was also fundamentally scary. So we'll put scary there. At least to me, it seemed scary. And it was scary for the exact same reasons it seemed exciting. In computing, everything changes all the time. What that means is that a lot of the skills that I learned in college would be obsolete in a few years. And at the same time my skills became obsolete, new people would graduate and enter the job market having mastered the latest and greatest new skills. So I imagine the life of a coder as being a life of always playing catch up to the younger people that had just learned the latest skills. And that was very scary for me. And that's why I decided I needed to learn statistics. Just like Beethoven's Fifth Symphony, the t-test that we use in statistics hasn't changed much in a long time. So in some sense, t-tests will get boring sooner or later. But with big data, we can combine t-tests with computing to keep things interesting. So with statistics, I thought I would get the best of both worlds. Something that doesn't change every 3 years combined with something that does. Bam! Now, the only problem was my statistics class. At least for me, it was terrible. Instead of using pictures to illustrate statistical concepts, the professor only used equations. And I'll be honest, I'm not very good at math. That surprises a lot of people, but it's true. Math is not my strength. Equations are not something I can look at and immediately understand in a deep way. Some people have that skill, and it's amazing, and I totally respect it, but that's not something I can do. So Statistics 101, which is the most basic in the US, that's the most basic statistics class you can take, was a hard class for me, and I didn't really learn anything from it. Sure, I memorized the equations and I could plug numbers into them, but I didn't really understand what was going on. That said, even though the class was a bust, it introduced me to the concept of variation. Up until then, I had never really thought about the fact that everyone has a different height. And I know that sounds obvious, but it's just not something I'd ever thought about before. And I never thought about how every time I order French fries, I don't always get the exact same number of fries. Or about how every time we treat someone with a medication, they don't always get better. So, even though the class was terrible, it opened my eyes to the variation that is in everything we experience. And I realized that not only is the world full of variation, but we can quantify the variation. And then use the information about the variation to make decisions. Like whether or not this medication is the best treatment. In other words, we can quantify variation as a way to help people in need. And realizing that statistics can help people was totally mind-blowing and inspiring at the same time. Bam! However, I still had the problem that even after 4 semesters, so that's equivalent to 2 full years of classes of statistics, the best I could do was memorize equations and plug in numbers. I didn't have a good understanding of what I was doing. So, because I knew I would be able to do good things with statistics, I decided to teach it to myself. Just like I taught myself programming in high school to make my game, Jimmy Quest. Teaching myself statistics was not easy and it took years, but I knew what I had to do. I had to translate the equations into pictures. Because for me, I can't understand something unless I see it as a picture. So, after thinking about it for a few years and making various attempts at understanding regression in a deep way, I realized that regression was just comparing residuals. Where residuals, are the differences between the observed measurements, the yellow dots, and the ones predicted by the blue regression line. Where residuals are the difference. Oops, we already did that. Anyways, then I realized that we calculate R squared, which tells us how well the regression line fits the data by comparing those residuals around the mean y-axis value and the residuals around the regression line. And we calculate a p-value for the regression line, which tells us how much confidence we should put in the predictions that the regression line makes by comparing the residuals created by fitting a line to random data Sorry, that's a long, long sentence. Anyways, we calculate a p-value by comparing residuals by fitting a random line to the data to the residuals around the observed data with the best fitting line. And then, using the pictures, I was finally able to understand this equation that I'd memorized all those years ago. All that equation is doing is comparing the ratios of these residuals, these different residuals. One's fit to a random line and one is fit to the best fitting line. Bam! Then I realized that all a t-test is a way to compare the residuals around the overall average y-axis value for all of the data to the residuals we get when we have one mean per group. The more the residuals shrunk around the individual means, the more confidence I could have that the data came from different groups and wasn't from a poorly run clinical trial where they messed up and gave everyone the same drug by accident, which is what the graph on the left represents. And again, the pictures help me understand this equation. Note, this is the exact same equation we used for regression. So doing a t-test is the same as doing regression. Double bam. Then I realized that all an ANOVA is a way to compare the residuals around the overall average y-axis value for all of the data to the residuals we get when we have one mean per group. And just like the t-test, the more the residuals shrunk around the individual means, the more confidence I have that the data came from different groups and wasn't just another botched clinical trial where everyone got the same drug by accident, which is what the graph on the left represents. And again, in the pictures helped me understand this equation. Note, this is the exact same equation we used for regression and t-test. So understanding this comparison, this ratio of residuals of these are the residuals around sort of a not optimal fitting line, and these are residuals around optimal fitting lines. When we compare those, the bigger the difference in that ratio, the more confidence we have that those best fitting lines might be a better interpretation of the data. Triple bam. As a bonus, the cool thing about getting a deep understanding of how residuals can be used to understand variation is that they also explain a lot of machine learning. For example, residuals tell us how regression trees work. So for a regression tree, we're basically finding a tree that fits individual means to the data, just like we did for an ANOVA. And once we understand regression trees, then it's a small step to understand how gradient boost and all of its associated methods like XGBoost, CatBoost, and LightGM use residuals to make classifications. Boop, 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 boop. Again, just like for ANOVA, we're fitting individual means to different groups of the data. And even neural networks use the exact same trick with residuals. Boop. So the neural network, all it does is fit a squiggle to the data as a way to try to minimize the residuals. Bam! Now, going back to when I finally had a deep understanding of how regression actually works, this gets us to StatQuest in 2017, 1 year after I started the channel. And that means I started StatQuest before I had a solid understanding of regression. I mention this because a lot of people assume I was born knowing this stuff. And that's not even remotely true. StatQuest has been my personal quest into statistics and machine learning and data science. So the videos that I put on YouTube, that's not me teaching, that's me learning. And each video that I make is a way of teaching myself a new concept. Anyway, in 2017, I was working in a lab helping these guys with their statistics. And at the time, StatQuest was just for me and them. As much as I wanted to understand what I was doing, I wanted them to understand as well. So what I was doing is I was making these videos because, well, before I made the videos, what I was doing is I was doing these Friday morning, what I called stat chats, where I would try to teach statistics to my coworkers. But it was an academic lab, and every 6 months we had new people coming and people going, and I didn't want to have to give the same lecture every 6 months. And I also wanted the material to be available when people needed it, not when I had time to teach it. And that was another cool thing about YouTube is, when they're ready and they need to know it because they're doing some work and they need to know what R squared is, they can watch the video then, rather than maybe I taught it to them 6 months ago and they've forgotten what it is. Anyway, I kept plugging away at my work and at StatQuest, making new videos as I learned new material. So that's in early 2018, I made a video on PCA. And then in late 2018, I did a gentle introduction to machine learning. And then in 2019, I made a video about support vector machines. And StatQuest grew into a relatively large YouTube channel for data science, which was really cool. Unexpected, but super cool and awesome. And I don't know, I feel very, very lucky. However, in 2019, my boss, Terry Magnuson, gave me some excellent advice. He said, you have to believe that whatever you are doing is the most important thing you could be doing. So in 2019, I was a professor in a relatively prestigious department, genetics, at a relatively prestigious school, the University of North Carolina at Chapel Hill. And even though I wanted to be a cello player when I was a kid, I also wanted to be a professor. So ever since I was a kid, that was one of my dreams. So I was living my dream. But to be honest, the dream did not feel right. It didn't feel like the most important thing I could be doing. Instead, StatQuest seemed like the most important thing I could be doing with my time. So I quit my job. Quitting my job, which had been a stable source of income and was a dream I had had since I was a kid, to do StatQuest full time was one of the scariest things I've ever done. But it was also one of the most important things I've done in my career. So here are the lessons I've learned about doing StatQuest and YouTube full time. 1, it's way more work than I ever imagined. Part of the reasons it's so much work is that it's the most important thing I can do. Sure, I need to relax from time to time and spend time with friends, but when I'm rested and able, I need to be working on StatQuest because I only have so much time on this earth, And I want to get as much of this done as I can possibly get done in that time. And there's so many more topics I have left to explain. And I just want to get to all of them. I feel like what I'm doing helps a lot of people. And the more I do it, the more people I help. And that's a great motivation, but it also makes me very busy. To just feel like what I'm doing is genuinely important. So if I don't, I feel like I'm just wasting time. The other thing I learned, number 2, is that it's way more fun and rewarding than I thought or imagined. I love helping people, and now I'm helping people all the time at all stages. Kids, students, professionals, even retirees are helped by StatQuest, and that makes me feel very good. Number 3, I spend a lot less time doing StatQuest than I expected. Running a YouTube channel is just another way to say you're running a business. And that means there's a lot of business stuff to do. For example, the StatQuest IT department, which is just me, has to troubleshoot my website when it goes down for some random reason. Or the StatQuest accounting department, which again is just me, has to figure out taxes. Or the StatQuest customer service department, again, me, has to keep up with the comments and social media. And the StatQuest publishing unit, which is just me, has to negotiate with printers. Then there's networking with other data science educators, and preparing for events like this one. And it all adds up to a lot more time doing things other than making videos than I expected. But it's okay. I mean, that's just part of the deal. I'm not complaining. I'm just saying, I had this vision that when I became a full-time YouTuber, all I would be doing 100% of my time would be just working on videos. And it's not like that. There's other things I have to do. And speaking of keeping up with comments and social media, I never thought I'd get hate mail, but I do. It's not like I'm saying nasty things about Taylor Swift or Kim Kardashian or saying bad things about certain football teams or something like that. All I'm doing is helping people with their homework. But I still get hate mail. So that's something I've had to learn how to deal with. That was something I didn't expect when I started doing StatQuest full time. So small bam. Number 4, although I'm already crazy busy, a few months ago I started working for a company called Lightning. They want me to make more videos about neural networks, and so do I. So that's why I decided to start working for the company. And it makes sense to collaborate with them since they have some amazing expertise in the field. Some of the biggest names in neural networks work for the company, and it's great because whenever I have a question, I get to ask them for the answers. So that's pretty cool. In a sense, I like to make hard things like neural networks easy to understand, and Lightning likes to make hard things like deploying neural networks easy to do. And what I like about this pairing of me and Lightning, which is I'm really happy about, is when I was in school myself, I'd learn things in classes, and then I had to get a summer job, and everyone would do things differently from the way I learned in class. And that disconnect between what I'd learned and what I was doing really bothered me. And I don't want my channel to be the same way. I've got a lot of videos that talk about the theory of neural networks and the theory of data science, and a few that talk about how to actually do it. But I want to do more. And I had this dream. I've had this dream for years of like a full-scale, a tutorial of a full-scale deployment of a neural network, going from a little thing that you've got on your laptop where you're just doing a proof of concept to a full deployment with like everything's on the cloud and we're training with a huge data set and blah, 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 all that fanciness. I'd say it's always for the past 2 years, that's been a dream of mine. And that's exactly what Lightning wants me to do. And so I could not resist the offer because I get to take advantage of their expertise and their tools, which help make this easy and make these videos that, in my vision, in my opinion, balance out my channel. And it's not too much theory. It also will teach you things that you actually can use in your work. So it's a good fit for me, and it's something I really enjoy. Anyways, that story gets me to where I am right now, giving this talk to you. So, are there any questions? Hello?
Hi, Josh.
Hello.
Yeah, we have questions. So people, if you have any questions to Josh, feel free to send them in the Q&A tool here on Zoom. And also, if you don't feel comfortable asking in English, you can ask in Portuguese as well, and I can translate to Josh. So yeah, let's go to the first question, which is triple bam. And yeah, the second question here is from Samuel, which says, "Hi Josh, I'm a big fan. I'm a professor in data science, and your way of teaching is an inspiration. How do you think the classes in the universities could be improved, since the professors are more interested in researching than actually teaching?"
Yeah, that's a great question. Here's kind of a funny story. When I was a professor in genetics, or maybe step back, a lot of people assume that I was a teacher, like I taught classes. And I'll be honest, I've never taught a class. Hold on, let me turn on the light. I feel like it's getting dark in my room. I've actually never taught a real class. And the reason why I never taught a real class is my boss, again, Terry Magnuson, the advice he gave me was, don't do it. And to be honest, I wanted to do it. I wanted to teach a class. I thought it would be fun. And he said, no, don't do it. So what I ended up doing, and why that was good advice from my boss, was when I started doing YouTube, I had no training, so I had to make it up on my own. I had to decide how I was going to teach rather than sort of following somebody else's footsteps. And as a result, I created my own way of doing it. And it's unique and it's weird, right? You know, when I do my presentations, I put the words on the board, so everyone can read what I'm saying. I just do weird things, but it works, and I'll be able to develop my own style. One thing that I remember though, when I was, so this is going to make me sound old, but when I was a kid and I was in school, people used blackboards, like they were like or a whiteboard. They had to, instead of using like PowerPoint to teach or slides, I use slides and I use them all the time. But before these things didn't exist, and everyone had to write them on a board. If you had something that a concept you wanted to explain, you had to draw it or write it on a board. And what I liked about that, but however, and that's the way it was when I was young. However, at some point in my life, they transitioned. The teachers stopped, PowerPoint came out, people started using PowerPoint instead. And what I noticed from my own personal perspective was that when people taught using PowerPoint, they crammed too much information in too little time. When you have to write on a board, you have a limiting factor. You can't teach more information than you can write on the board. So you can only write, you can only write so fast, and so you can only teach so fast. But when you can put all the data you want on a slide, and you don't actually have to manually write each thing in front of people while people watch, you can cram in more stuff. And all of a sudden, teaching moved too quickly and it went too fast. And so that's something I try to do with my videos, is keep a relatively slow pace. So that's me, the student, because I'm my own student, basically, can keep up with what's going on. So, but to be honest, to answer your question, like, when the universities do emphasize research, and that's a problem. I mean, research is helpful, and it's good to have professors that are doing cutting edge things. But they have to have their heart in communicating with students, and most professors don't have their heart in it. Their heads in their research, and they're not thinking about communication. Maybe more training on why communication is important, why it's important for other people to understand what's going on, not just for teaching, but also for presenting their own research. I don't know how many research presentations I've gone to where the presenter just assumes you live in their head and you already know what they're talking about. That just drives me crazy, because I mean, if you're not communicating with somebody, you're basically, it's rude. It's being rude. It's being impolite, and people don't recognize that it's a bad habit and it needs to be corrected. But to be honest, I just don't know what the solution to. But I will recognize that there is a big problem there. So there you go.
Yeah, I think the analogy to the blackboard, actually in Brazil, I believe most schools still use blackboards as the main source of teaching, and PowerPoints as complementary tool.
Yeah.
So yeah,
that's probably for the best.
Yeah, I actually prefer the blackboard, especially because it makes more digestible the information.
Yes.
So yeah. We have a question from Leonardo, which says, "My name is Leo, and I've just finished my master's in business analytics at Imperial College. I believe it's London. My classmates and I are huge fans of Josh's work. You really make data science less daunting. I think that it's hard to estimate the impact of StatQuest on our lives. I believe that one of the main ideas behind your work is to render data science accessible. I believe that one of the main hurdles for many Brazilians might be the language barrier. While it is true that people can use subtitles and other tools to understand your content, I wonder if dubbed versions of your videos could help render your content even more accessible. Are there any plans in this direction? If so, how could data science around the globe help you?
Yeah, so that's a big thing, and the good news is I have plans. They're not. It's not. The good news is there's I'm part of this experimental program with YouTube, and on the bad side, what they're doing is they're doing an AI translation that I then okay. So here's what they do. They do an AI voice to text. They take what I say and they try to make it text. I then edit the text and make it correct. And then they translate that into Spanish and Portuguese overdubs. And they've done this for my new videos. So if you look at my video on long short-term memory neural networks, there's a button in the, I don't know where it is, but there's a button on the video screen somewhere where you can click and you can select different overdubs. You can select different languages for the overdubs. And they're adding more languages to this. And hopefully one day they will allow me to apply it to my catalog of videos that I've released before. Right now, they only do old videos. And this is where I could use help from data science in different countries, because for a couple of reasons. One, to go through, I've got like hundreds of videos, right? So for me to take the time to like edit and correct every single one and then sort of validate the translation would take forever, and it would prevent me from making new material. And so that would be something that would be awesome to be able to crowdsource that with data science experts that live in different parts of the world or are fluent in different languages that could help out with making StatQuest available in more countries. I totally believe it, that would make things better. And it's something I really want to do. And I think we're really close to doing it. So I'm excited about that. So there's a solution on the horizon for the whole catalog to be translated. It's just a function of one. They just have to switch this option on so I can do it for my old videos. And then once that happens, I'll make some announcement on it, and I'll say, help, I need help. And maybe you can help me out. Yeah.
That's amazing to see that it's already planned. It's something that it's gonna happen. So it's awesome news. We have a question from Rafael. Are the videos you were working with Lightning publicly available?
Yes, they're all free and publicly available. And they're coming out I'll be honest, I'm slow. It takes me forever to make a video, but they're all free and publicly available. And the other thing that's nice about them being from Lightning is this may or may not affect you, but they should have less advertisement interruptions. They should have no advertisement. There might be some at the very beginning because YouTube will just stick those on no matter what. But sometimes they'll stick video ads in the middle of a video because some of these videos are really long, and they'll try to break it up with ads. And I've put in a request to block those because Lightning, to a certain degree, is financing these videos and supporting them. So they are free and available. And if you look at any of my recent neural network ones, like that long short-term memory neural networks video, that was financed and supported by Lightning as part of this campaign to help me teach neural networks. So it's a pretty good deal. They're incredibly generous because they want everyone to know this stuff too. It's not like they're not making like a paywalled thing that you have to like become, a paying subscriber, or you don't even have to give them your email address, or anything. You don't have to sign up to anything. You can just watch the video and enjoy it. However, there is one little thing. So a lot of because these are applied videos, what I'm doing is I'm creating Jupyter notebooks for the code, and I'm actually putting a lot of time and effort in these. These are beautiful. It's code plus the story behind the code, explaining every single line, with pictures and everything. It's basically, it's almost like a small book about how to do things with code that you can run. Imagine a color book that has code you can run. These are also free and available, but you have to provide them with an email address. And that puts you on an email list where once a week they send you like something, but it's not that big a deal. I actually like this. They send out a newsletter, and I actually like this newsletter because for me, it's hard. There's so much going on in the field of data science and artificial intelligence and machine learning. There's so much going on that's very hard to keep up. And they send out this newsletter, and it's just a brief digest, a real like one paragraph of like just the highlights of what happened in the past week. And it helps me feel like I'm up on things. So to me, it's a small price to pay. And actually I like this newsletter. So it's not even a price. It's like getting 2 free things. But yeah, you get a little bit of marketing, and that's okay. I feel like, they deserve something for this effort, but this code that you can download is fantastic. I mean, I personally think it's fantastic because I wrote it, but yeah, it's cool. You can check this stuff out.
Oh, that's awesome.
Yeah.
Actually, regarding your videos, you told about your hard work with the Jupyter notebooks. We have a question from Jane, which says, "Hi Josh, which video was the most challenging one to create?"
That's a great question. I mean, the hardest one are the ones that I've been working on for years and haven't made yet because I still haven't solved them. But I think the original linear regression video was one of my hardest. That just, you know, I had to learn so much and had to try doing things differently in a way that I'd never done before or I'd ever seen before. So that was a really hard one for me because I was basically creating everything from scratch, at least in my own way. The other two that were really hard for me were PCA, principal component analysis. That I spent about 2 years on that one. And the other one was I have an introduction to neural networks. And that was another one that I spent years working on. And there's a funny story about that one. And there's a lesson I learned from that video. So let me tell you that lesson. There are a lot of great resources for teaching neural networks, and I thought they did a great job and they'd explained it. And I thought, to be honest, I thought I understood what they were too already at that point, just from these resources. And but people kept asking me in the comments of my videos, they would say, Can you do a video on neural networks? And I'd say, I mean, maybe I could, but look at this. And I'd send them links to other stuff that I thought was already great and say, you know, do I really need to do this video? Because it's going to take a lot of time. And there's other things I could be doing with that time. And they were like, yeah, you need to do this video because those other resources don't work for me. I need something else. And so I got enough of those comments that I realized that I needed to go back and I needed to look at those things, those resources that I like so much. And I had to figure out what was missing. What were they not saying? And that's been a big lesson for me in general. When I want to teach something, what I need to do is I don't need to repeat what people say. What I need to do is I need to find out what they haven't already said. And that's what I need to say. I need to come up with a way that I can complement what other people are saying and not just repeat, but find out what they haven't said and work on that. And that's what I did with neural networks. And when I did that, I was like, well, what are they missing? I was like, well, nobody shows. I mean, they show the math in kind of like abstract terms. You see a lot of linear algebra. And you see a lot of even with graphical representations, you'll see lots of circles with lines, but you don't actually see the math being done by hand. And I was like, well, no one's doing that. So I wonder why not. And so I decided I would try it. And what happened was I suddenly realized when I did the math by hand, and I did it for a bunch of input values. So this took a long time. And I ultimately wrote a program to do it for me and draw the graphs at their various stages. I finally understood how neural networks work. I thought I understood how they worked before. But once I plugged in the numbers one by one and I did the math by hand, all of a sudden I got it. I realized that all that neural network is doing is fitting a squiggle or a shape or a line to the data. And the way it does it is it takes these things called activation functions, which are just sort of bent lines or squiggles themselves, and it cuts out a small piece of that function. And then it stretches that part of the function, or it compresses it. It can stretch or compress it, and it can flip it over, it can rotate it, and it takes that piece and it adds it to another piece, and it adds these pieces together. And as a result, it can fit any shape to your data. And once I saw that, I mean, it sounds abstract when I'm just talking about it, but once I saw it, my mind was blown. And I was like, everyone says neural networks are black boxes. They are not black boxes. You can actually see exactly what they're doing. And I was just like, oh my gosh, I get it. And it was one of the biggest moments for me. I was in the history of StatQuest. I just remember being so excited. It was a big thing.
That's awesome. And we actually have a lot of questions about one specific topic, which is what's your preferred way of studying for a topic? So
yeah.
about creating. So is it doing the math on hand or reading or more of a visual learner?
Yeah. So, I mean, I read everything I can find. That's the very first step is I open up a web browser window and I do a search on the topic and I open up about 30 different tabs, maybe even more than that. And I'll read every single one of them. And to be honest, like I'll pull up the Wikipedia article and it won't make any sense at all. And I'll get halfway through and I might fall asleep because I don't understand any of it. And I'm like, ugh. And so I'll skip to the next one and I'll read that and be like, I don't get this either. And I'll skip to the next one and I'll be like, oh, still don't get it. And I'll keep going. And to be honest, I might go through all 30 articles, all 30 tabs without understanding any of it. And that's a little embarrassing. And I'll be honest, this still happens to me. My hands will start to sweat. And I get nervous that this will be the topic I fail. I can't explain and I can't learn. And I'm like, oh no. And I get a little nervous. But I don't give up. That's the thing. I don't give up. What I do is I just go back to the beginning and I read everything again. And be honest, it still doesn't make any sense. However, when I read everything twice, the second time I start noticing that certain words and phrases appear a bunch in the different articles, all 30 articles. People might say, activation function. And I'll go, okay, I may not know what a neural network is, but I need to know what an activation function is. So I'll open up a new browser and I'll research activation function or whatever the other term is, residual or sum of squares or something, whatever that term is that I don't understand. I'll open up a new tab and I'll learn that whatever that term is. And then I'll learn that once I learn that term, I'll go back to the original tab and I'll try reading again. And now that I know what some of the vocabulary is, I start suddenly learning, and it starts making sense to me. And then, so once I have a general idea, it's vague, I'll try to find a package, a software package that implements whatever it is and see if I can't make a very simple toy version and make it work. And chances are it will fail. Whatever I'm doing on my own will fail. And the results will be completely different from what I expect. But what that does is it gives me another starting point to try to understand where am I confused? Why are things not working the way I expect them to work? Sometimes that means actually looking at the code. Like that's what I love about a lot of the Python stuff with scikit-learn is you can actually see the code. You can go to the GitHub and you can look at the code. And I've gone for a lot of the things, I've had to go through the code to see how it works. And then, so I'll start learning that way. And eventually I'll get to where my little pretend thing, my little toy does what I expect it to do. And once it does, I start drawing pictures. And that's sort of like the way that I validate that I understand what's going on. When I can draw a picture of what's going on, that's when I know I finally understand. And it's a long, very tedious process. And it's full of self-doubt. It's full of me thinking, I can't do this. This is too complicated. I mean, I've done other things in the past, but I've never done something as hard as this. And I don't think I can do it. I doubt myself every step of the way. But the thing is I do not give up. I might put something to the side. I might go, I've done this for a couple of months and I'm not making any progress. I'm just going to put it to the side. And then I'll go and I'll do something else, but I'll come back to it and I'll try again. And I will just keep working on it until I get it. That's my secret, is I just don't quit. And eventually I learn it. And that's my trick.
That's amazing. This phrase of just don't quit, I think it's really powerful.
Yes.
I'm gonna launch a poll here.
Okay.
So for people that are watching us, we're gonna launch some questions here. So yeah, feel free to answer them. There are more for us to know you and to get to know our audience. And I'm gonna keep this poll active for around a minute or so. So during that time, we can go to the next question.
Okay.
And we have a lot of questions actually. We have one from
Yeah. Unfortunately, yeah, we can keep going, but I can't go all night.
sure. Sure. Actually, we can go for two more questions.
Okay.
Uh,
Sounds
okay.
great.
So we have a question of Arthur, which is, "Hi Josh, how are you doing? Are there any plans to make videos about Transformers architecture and the models based on it? I love your videos. Thanks for the great work."
And the answer is yes. Yeah. So, yeah, I'm really excited about doing Transformers. The limiting factor right now is I have to learn about them. And I'm using this process that I just described, which is very slow. And, but it is the dream to ultimately do Transformers. I hope have them out in the spring. That would be huge. What that means I have to do in between now and then is I got to make a video on encoders and decoders. I know I have to do that. I may have to do a video on attention, but maybe not. Maybe that's just all a transformer is. So there's a couple of steps I may have to do, but between now and then. But yes, transformers are on the list with the highest priority. Yeah, I'd say the highest priority. I don't think there's anything on my list that has a higher priority right now. I'm really excited about them, but I have to learn about them first. And I just learned about long short-term memory, so I've got a long way to go.
Yeah, I'm looking forward to it. And yeah, we have our final question of Isaac, which is, what tips would you give to anyone migrating to data science or starting out in the field?
Yeah. One, take it slowly. It's a big, huge field, and it's easy to feel like you have to learn all of it by next week. It's easy to be overwhelmed by how much there is to learn, because everyone around you is like, they've been doing it for years or whatever. Or it just sounds like everybody knows everything and you know nothing. That's okay. Don't freak out. Don't panic. Don't rush it. It takes time to do a good job learning. Learning is, it's not something that you can just plug a chip into your brain and you all of a sudden know stuff. Part of learning is repetition, and you can only repeat things if you allow time to be part of how you learn. So give yourself time to learn. Don't expect yourself to know it all now. Take it slowly. Just beat at it one piece at a time. So take your time and don't feel bad that you don't already know everything. What other tips? StatQuest, obviously. But also, just do what I do. Just Google and find everything you can. My videos are one way to learn about things that may be good enough, but there may be something else out there that's better. And always look for that better thing. Something that might resonate with you more. Just be curious. Try to, don't take things for granted and go, well, it's just the way it is. Try to understand what's actually happening and go, okay, so what's really happening? Why does this really work? Why can I trust this? Why do I have confidence in this? You need to answer those questions. And those are hard questions to answer. So don't feel bad or dumb if you can't answer them immediately. That takes time, and that's part of the learning. The other thing is, which tools should I learn first? And that's just a really subjective thing, and it really depends on the environment you're in. So look around at what the people around you are using. And I hate to just say go with the herd and go with the majority, but do it, because those are the people that are going to help you, and you're going to need help every step of the way. I need it all the time. That's why I'm working with Lightning, because I know I need help and they can help me. And I see one of the other questions. Someone said PyTorch or TensorFlow. I say PyTorch because the people around me do PyTorch, and that's my support group, and that's my help. And when I have a question, I can ask them. And so if you're going to learn Python, or you're going to learn R, or you're going to learn Tableau or whatever, just look at what everyone else is doing around you and just learn that. That's not the only thing you'll ever learn. There's other tools you will learn in your lifetime, but to start, just learn what the other people around you are doing, because that's how you're going to get help. And you need help, and you want to have people, that you can meet up for coffee and you can say, hey, I'm working on this program, or I'm working on this problem and I need help. And they can go, oh yeah. And they can help you out in person. And I just think that's the best way to go. And I know that's a vague answer, and it doesn't really answer it specifically, but you just look around and use what other people are doing. Yeah. Hooray. Uh-oh. Victor, I think you're muted.
Oh, I didn't notice. Thanks. So yeah, that was our last question. Thank you so much, Josh, for being here tonight with us. I hope this meetup will be as valuable to our audience as it was to me. So yeah, thank you so much. Thank you, everyone. So yeah, bye-bye. See you on the next edition, and subscribe to StatQuest. So yeah.
Thank you very much. It's been great being here. Thank you, everybody, for your patience, and hopefully we'll get to do something like this again. Hooray.